So, painless JavaScript testing, it is a thing, believe it or not. Many people don't believe this, and I keep trying to prove to them that it's possible. So, let's start out with a couple of things about myself. I'm a father of two sons, and I went from business to software engineering. The reason I'm listing these two facts is that I haven't been in the software world for long enough to show my experience. So I needed to come up with something that inspires confidence in people. So having two kids, I assume, inspires confidence in people, and yeah, I'm responsible. I have kids. So what will I talk about? I'll talk about, oh, by the way, Iris mentioned that I've been notified about this at 4 p.m. So I'll be using slides as my cue, and bear with me as I'm trying to figure out what did I mean to say by this a while ago. So apologies in advance for that. So what will I talk about? Painful tests. First I want to get everyone on the same page about what testing means, what do I mean by certain terms, and why testing can be painful. And then I'll cover different ways to test things. All of the different layers of testing that I'll talk about today, we use at the company that I'm working at, which is Nested. You can see the name confidently at the bottom right corner. So yeah, let's get started. So is just JavaScript testing painful? Can I get a show of hands from people who think that testing is painful? Can you raise your hand? Oh, pretty much everyone. Great. This is going to be a great talk. Not for me. So, automated tests. Let's begin with very basics. I want to make sure that we are all on the same page as what do we mean by automated tests. And for me, automated test is something like this. You have some sort of function that does things, and then you test that function. So why do we need tests? I'm not gonna ask you people. Speed is one thing. For me, when you start working with tests, and especially when you do test-driven development, it's actually faster for you to iterate on features. It's much easier to come up with what you actually want a function to do, come up with a set of inputs and outputs, and only then try and figure out what needs to go into that function to make it happen. And I'll show examples of real life examples where it's actually easier to work with tests rather than try and emulate that particular scenario that you want to test. The second thing is certainty. So tests provide you certainty that your things work. I remember the first time I gave this talk, so right now it's 8 months ago, we were at a place where we weren't confident that if our test suite passes, if RCI build is green, we weren't confident that we can actually deploy and be calm and go home. Whereas now I think we are at a place where we have automatic dependency updates for us being merged in automatically if test suite passes, where we are really confident that if our test suite works, we are in a good place. Obviously things still break, and we still find different ways that we can break our production app. Who can't break their production app in interesting ways? But the more and more we invest in testing, the more we patch all those different things and test apps in there's different ways that it becomes harder and harder for us to break it. So what makes testing painful? Personally, I think that testing is quite nice. I did have those moments when you write your feature in a couple of hours or less, and then spend days or weeks trying to test the hell out of that thing, and you can't just make it work. You can't just make the test work, which is really frustrating. But I feel that this was at the beginning of a journey. Once you get the hang of it, once you understand the general principles that you what do you need to test, how do you write good tests, and how do you actually make sure that the tests that you write are resilient and not fragile, this is when things become quite nice. So it does have a learning curve, but yeah. So learning how to write tests. That's part one. A lot of time when I ask people I can actually do this now. How many people can you raise your hand if you think that JavaScript testing is painful? Yeah, if you think that JavaScript testing is painful, please raise your hand. A lot less people, yeah. And if you have written more than 1,000 JavaScript tests, please keep your hand up. Okay, so there's a lot of people who have written a lot of tests and still think it's painful. Then I guess like the second part will be for you. Like the first part is for people who haven't like written that many tests and they're like still new and still trying to figure out what the hell I'm doing with those tests and why do I need to write it. This is like the first part why it's difficult. There's no clear consensus in the JavaScript community, like how do you need to test this? There's like a lot of tools. There's setup required to get started. You need to learn about mocking, test scope, etc., etc. So there's a lot of stuff that you need to like learn about good testing. And the second part is like learning how to write good tests. And that's where it's very easy to fall into a trap where you like keep writing unit tests and like testing minimal parts of the app. As soon as you change something, your tests break, and basically just like write tests that have a direct one-to-one relationship between the code that you're writing. So it's like double the amount of code with zero value for you. The tests can be slow, flaky, hard to read and understand. I've seen that a lot. Some of them are like really useless, but like there's no way you can break your test without changing the functionality. And it's like, what? You're literally writing the code twice and getting no value out of it. And like low coverage to effort triggers, like there are some tests where just like it provides you some value, but the value is so small compared to the amount of time that you like need to write it, that in some cases just not worth it. Because all in all, like we are all in business environments and we need to like provide business value, so we need to write tests that actually save us time rather than just like spending time writing those tests. There's a great YouTube talk by Aaron Abramov. He's not a brother of Dan Abramov, but he's a good guy. And he talks about delightful JavaScript testing with Jest. I highly recommend this. There's a lot of things that I've learned from that specific talk and applied in practice, and that was really, really helpful for me. And one of the things that he talks about is iteration. Like, it's the same as writing a good piece of code. You don't write code that's perfect. You start with something that works, you apply this in practice, you learn about different things, and you iterate on it, and your code gets better and better, and that particular feature gets like more and more clean and nice. And it's the same with tests. You need to find good ways to test your application, and there's also like different ways how you can like test your applications. The applications themselves can be very different. Like there's a big difference when you need to test a static marketing page that you like use some third-party API to like get content, and then you test like an internal app that's being used for like admin purposes and a lot of data entry. There's like two different applications which are both written in JavaScript but require completely different kinds of tests. So it's important to like continue iterating. And that's when you can like arrive to delightful JavaScript testing. Disclaimer, I myself, I'm still learning a lot of stuff. A lot of things that I'll talk about, I'll caveat them with like things that we are currently stuck on. And if you have any answers that you would like to teach me, I'd be really happy if you could like, approach me and tell me, oh, like you actually need to do it this way. I'd be really grateful for that, because you never end learning. So what makes testing delightful? This is kind of obvious, like it's the opposite of what we've just talked about, like minimal setup, clear consensus, fast test, reliable test. Yeah. Cool. So let's get into the nitty-gritty details. So this is where I'll start showing real pieces of code that we actually use in production that's like I've worked on, and there's like a git blame with my name on it. So we use Jest. The reason we use Jest is the syllabus is fairly minimal. It's very easy to get started with. There's a fairly clear consensus of like the best way to write tests. Now that I'm saying this, like there are a lot of ways to write tests, but like it's fairly hard to like write bad tests. No, I'm not gonna say this. It's difficult to write tests with Jest, but it's the best so far that I've worked with. And the important part is it has blazingly fast tests, right? Who doesn't like blazing fast tests? Custom matches is another thing that I found out about 6 months ago. It's it has been an interesting experience. I'll talk about this later. So what do we use integration tests for? For us, most of the time that we spend writing integration tests has been for the internal app that's being used by like 50 to 60 people. And it's mostly about like data entry and the connection between GraphQL in the front end and the GraphQL server in the back end, and basically making sure that each part of that app has been set up and connected properly, and data is flowing from the right place to the right place. So let me show you some code. Sweet. So this is the specific session that I'll be talking about and analyzing today. This is a fairly simple data entry section with 5 fields, some date fields, some radio buttons. And this is the code for that section. So effectively, we use Jest as grid. This is the layout of a section. And immediately you can see that we use flow as well, but let's discuss this later. So you have fragments like radio buttons, date pickers, some conditional fields, nothing too fancy, a mutation to send to the backend, property of a field. And this is the outer layer that injects things into the management component. So it's like 138 lines of code. Our app is like peppered with these sections. We have like probably hundreds of these sections. Maybe not hundreds, like maybe 100 plus. So this is the test for that particular section. So the test is 96 lines of code, so you can already see that we have less lines of code for testing. However, I have very good confidence that like if we ship this code, it's gonna be good. And I wanna get a git blame, but I can't. So effectively, like I haven't touched this section. I haven't touched these tests or this code since I've given my talk roughly like 6 months ago. And I'm surprised that like things have worked really well. Bugs have been caught, and our tools in general didn't change that much. So I'll dig a little bit deeper into like how things are structured, and I want to ask a question. Who here has worked with GraphQL before? Raise your hand. Okay, not that many people. So I'm gonna give like a short outro of like GraphQL. GraphQL is an alternative to RESTful APIs. It's a single endpoint that you send your GraphQL queries to, and it effectively allows you to dynamically ask for things that you want back from your server. So with REST API, you have like multiple endpoints. You have get and post and put, etc., etc. With GraphQL, you have queries, so an equivalent of GET requests for your RESTful API. Oh, by the way, who knows REST here? Okay, I assume that somebody knows either REST or GraphQL, hence why I'm like comparing REST to GraphQL. So queries are equivalent to gets. Your posts where you want to like send something, and puts are equivalent to GraphQL mutations, and that's about it. That's like the main bread and butter. You have like subscriptions in GraphQL, but I'll not go in there. So the first thing here is we are importing two things. We are importing mount with providers and resolve queries. These are the two main helpers that, again, I've written like 6 months ago that we use to mount our section. And let's actually get in there. So let's cover everything. So we are using Apollo's in-memory cache, so that's effectively, okay, who here knows about Apollo client for the front end? Okay, so basically those people who know GraphQL know about Apollo, because that's one of the more popular libraries. Those who don't know GraphQL and work with REST endpoints, Apollo helps you with managing your queries and mostly like caching the responses that you get from your server back, and is effectively like a layer that allows you to effectively send the queries that you want to the backend. And this is a tool that allows us to mock that layer so that when we actually like want to interact with our server, we are interacting just with a piece of code and no network requests are actually going out. It helps to make our tests faster compared to actually like going to the server and doing stuff. So some cache, Apollo client, fetch the actual client, schema, mount from enzyme. Who here has used enzyme? Okay, a lot more people. So enzyme is effectively a tool that allows you to mount your app on a virtual DOM and do assertions against it. It has a very similar API to jQuery where you can like find items on it and do things with it. And as far as I know, it's like enzyme is mostly like used with React apps, but I'm sure you can use it with other tools as well. So yeah, so we use enzyme to mount our app. We are getting providers. I'm not going to go into providers, but like, okay, I'll cover it shortly. So providers is like the three top layers that I believe are necessary for most of the apps. So one is Apollo provider. It's the actual provider that is the layer between our front end and back end. So it connects those two pieces, and that's where all of our requests to the backend go through. We have a theme provider, so any app that you style probably has a theme, so you want to be able to like switch your theme fairly easily if things change. And finally, the router. So this is the stuff that is necessary for an app to behave like an app, to like have routes and have proper styling injected, etc. Going back to this, let's close. Yes, code is really good. So yeah, so we have default mocks. Let's get into this as well. Effectively, default mocks is mocking data types, and I'm like really going into the detail because I think it's interesting, and you're gonna have to suffer with me. So mock history again is a mock version of actual browser DOM's history, so that we can mock it and make our app behave the way we want it to behave ourselves. So this is where we get to the interesting part, the amount of providers. This is being used in every single test. We get a React element. So if you look into the test, we get a React element. So it's the same management pack that we actually like mounting on the page. We create that value. There's a bunch of things that we can provide it. So we can provide query resolvers, which is mocked GET requests or queries, mutation resolvers, which are like mocked POST requests or mocked mutations, and resolve types and mocks, and a path for an actual route that we want to mount our app. So some stuff to like set up things. If we have a path, we want to mount our app on that particular path. We want to put all of the like mocked backend responses and front-end responses into the schema, which is another thing that I'm not going to show you. Effectively, it's a huge JSON object with all possible responses from your types of responses from your server. So we are adding that, some fragment stuff, and yeah, finally, like we are injecting by component. So we are putting all of those providers, like wrapping your component with all of those providers, and at that point in time, it's like actually mounting your app. So effectively, when I do this, it's the same as if I mounted that section as it was my app. So that thing, like literally I've written it like 6 or 7 months ago, and it hasn't changed since then, because it's like the basic setup. Once you have it, you can do interesting things. So this is the beginning of our test. We are testing management pack, all fields. And the first test is we have 5 fields. And we are testing that those 5 fields are getting back the right values from the server. So like we are connecting those fields with the server so that when the server gives us some value, we want those fields to show that value. It's like the basics of a data entry app. You want to show the stuff that's on your server. Before we do this, we need to set up some mocks in the server so that server actually has those values that it can show. And this is our default response. any updates that we are applying to it, and effectively buyer offer is that type that this section queries. So this is where we are like responding with that default response, and at the same point we are setting up any updates. So basically this create resolvers acts as a fake backend for us. So it gives us a default response, and if we send something to it, it gives us the same thing back. I'm not going to go into like mocking errors or things like that because we won't have enough time. So we've set up the backend, we've set up some default responses, and now you can see like expect the wrappers, like expect that app that I've just loaded, that component and providers, expect it to have a field with a certain value, which is false. So this thing is hopefully new to all of you, and that's not part of the traditional enzyme library. It's actually a custom matcher. So that's one thing that I mentioned before about Jest, which is quite cool, and that is custom matchers. So let's look into the custom matchers. I'll cover this later. So this is a custom matcher. This is like to have field with value. The underlying reason behind custom matchers is that in your tests, there will be a lot of boilerplate that you will need to write. So as with any good code, you'll want to abstract that boilerplate away so that you could like write small assertions that actually do the thing that you want to do and be done with it. So to have field with value is effectively like the basic test. And let's see what it does. So one thing that I'm doing, I'm literally testing whether there's a data test attribute with the field name that I've passed. So you can see here that I've passed in management pack received done, or like management pack license to assign completed. I passed this field, and I'm testing whether I'm finding that field. So this is like the basic test, like can I find that thing? A small detour. Data test, I highly recommend you stop using class names, IDs, tag names, element names, whatever else you're using, and start using data test attributes. This is one of those things that will save your lives one day, and it's a bold statement. But effectively, I have lost count of how many times people removed IDs or changed classes or changed the name of a component and broke the test without realizing it. There's like with data test attributes, like you are telegraphing to everybody who's looking at that code. This is what I'm using for test. If you're gonna like move it away or like do something with it, you'll break things, like you'll break my test. So if you want to preserve tests and if you want like the test to behave in the same way, you'll know that you'll need to like port this, and it becomes like much easier for you to actually use one thing for tests and don't mix like styling or like naming with actual testing pieces. So back on track. If you're adding a lot of data test attributes everywhere, like you're littering your app, adding a lot of data test attributes across things in your app, you are taking up memory, and does that affect production, and how do you deal with that in production? So there's a couple of options to that. Like first of all, like for us, there hasn't, like I haven't had any problems with that yet. Admittedly, our app is being used by like 60 or 70 people internally, and they like all of them like have latest computers, and like we don't have issues with that. So if on mobile phones, I don't know if that's an issue. Secondly, if that's really an issue, there are scripts that can easily like strip all of the data test attributes for you in production app, because presumably on production app you aren't really testing anything, so you can just like strip those away without any issues and preserve them. So it's like a minifier, and you just like kill those attributes. So that would be like my approach with dealing with it. If you have issues in terms of like performance with those data test attributes, strip them out in production. But in most cases, well, I just haven't experienced that yet, and maybe I'll run into this later. So thanks for telling me this. So going back to this, so the first check is like we are checking whether that element actually exists in the thing that we rendered, and the second one is like very interesting, like very simple, is we are just like checking whether we get the value. We can find that value on that element. If that value is the same, or if that value matches the value that we expect, that we are expecting to have. So as you can see, like the second argument that we are providing is the expected value. If it matches the actual value, we return pass, and if it doesn't match it, we return false with a custom error message. And that's the custom error message bit here is the one that actually is really helpful for me. I found that it really helps people who are new and who haven't like written many JavaScript tests. For example, like at Nested, we have people who work across the stack. That means that some people will be strong in the backend, some people will be strong in the front end. There'll be new joiners, and everyone who's new, they'll need to like learn your way of writing tests. By doing custom matches, you can give those people helpful hints and tips when they like encounter like commonly known errors. So one example is like, if field doesn't appear in a wrapper, it can be like really frustrating, but because you don't know what happened and you don't have an idea of like how to debug this if you're new. Like if you just like came from a backend from a different language into this like JavaScript world, something broke and like I have no idea why. So in that error message, we can actually give them some tip, like look, to see the structure of your wrapper, just like wrap it in console log wrapper debug, and you can see what you actually have. And that sort of like help just in time can save those people like questions that they would need to ask you, and you can like teach them as you go with those like custom messages. I found this to be like useful, and I've heard people like people being helped by this and like learning things here and there. So I think this is useful. So yeah, that's one. The other thing is like we have a little bit more complex setup for testing mutations, and again, mutations are requests that we send to the server to update the value. So for mutations, we do the similar sort of check. We are checking if a field is there, and yeah, one thing that we are doing. So basically, with this particular matcher, there's two goals. First goal, we have optimistic responses. Optimistic responses are effectively our way of assuming what will come back from the backend, so that we can update the UI immediately without having to wait for the response from the backend. So for anyone like who hasn't worked with GraphQL and is not aware of what optimistic responses are, it's basically I send the request and I mock the response by saying like, this is what I think the response will be, update the UI with that response. So the first part of the check is effectively checking whether after I've fired the mutation, whether my optimistic response updated the UI with the correct value. So this has happened a lot to people where like I've had cases where people told me like, look, this doesn't work, like, and like I can't figure out why. Like my feature works in production, but I'm writing this test and this test is like just breaking. And when you actually like look into the test, that test was telling that your optimistic response wasn't configured properly. And that person, because he like was working on like a really fast computer with really fast network connection, the response from the server was coming back so quickly that the optimistic response like just didn't have enough time to see that optimistic response. So we didn't notice this, but like this does really help them out without them realizing it. So like they've received value and they've been like stopped, and we had a chance to like talk about what optimistic responses are and how do you like properly implement them. So that's the first bit. Did you set up your optimistic responses properly? The second bit was, did you actually correctly show the new value that comes back from the server, right? So again, like you need to make sure that your component properly updates and re-renders when you show, when the server updates the value. So if there's an error message, you want to make sure that like you are actually properly rendering like an error component, and if the value is all right, you want to see that the value is there. And you can see like all of these custom matches have those like custom messages that just like have nice and like, helpful tips for how to debug this situation if something goes wrong. Sweet. So tips from practice, like well, this is like the end of my talk about like the integration testing part. Helpful tips from practice is that once you have a good setup, the most difficult part for people is actually mocking the backend and understanding how the backend works. Because when you work in the front end, you're in the front end mindset and like you expect things to happen in a certain way, but you forget that you like need to implement the backend. And effectively, if you have a backend, it's very easy to forget that like, oh, I actually need to like do my own backend here. So that's one part that I've noticed people struggling a little bit. And I think we are still looking for a good way to like mock the backend, because mocking the backend can be difficult, especially when you like deal with lists and then you like need to delete entries, create entries. That's when you like need to know intimately how your backend actually behaves, so you can like properly return like a good response. Because like in some instances, if you delete something, you need to return like the underlying object, etc. So like you need to mock a different thing than just like that one thing. So again, like it's really good for like full stack developers, because they can like deepen their knowledge about like how frontend consumes it, and at the same time like play with the backend and build backend in a better way, because we actually have to like mock it and like build it the second time, so that like it's very good practice to like for your like design skills for a backend. So yeah, GraphQL tools is awesome to actually really like help a lot. You've seen the setup was fairly minimal for like the whole backend, and then every test has its own specific backend implementation. Unit testing, that's like, who has done unit testing? Raise your hand, please. Okay, a lot of people. Who has done integration testing before? Okay, the same group of people done both types of these testing. I'm not gonna ask like what's the difference between unit testing and integration testing. I'm gonna like just tell what I think it is, and it's very different for like different people. So for me, integration testing was like, again, like about testing the connection between like front end and back end, whereas like unit testing is about testing like the smallest possible unit, and in JavaScript that's like usually functions. So I don't unit test much more than like a function or a single component. So shallow rendering, yeah. If you've used Enzyme, shallow rendering and mounting is like the line for me between like unit tests and integration tests. With like shallow rendering, you're like rendering the smallest possible bit, and that's where like your unit is. And with like mounting, that's where like the whole party begins. So I'm gonna quickly show like how do we use unit tests. So for that same component, same management pack, you may have noticed or remembered that some of the fields are conditional. So for example, if you have management pack as true, if that button is toggled to true, we need to show 2 extra fields. If that button is toggled to false, we want to like hide those fields. So this is literally what I'm testing. Just like mounting that component. Initially, I'm mounting it with an empty object, meaning that it will default to false, and I just expect those fields to some fields to be there. So 2 fields that are non-conditional to be there, and the conditional fields to be hidden, and then like testing the appearance of conditional fields if the value is actually true. So that's unit tests, like simple bread and butter. In practice, I actually like use integration tests a lot more than unit tests, mainly because there's a lot more value to be gained with the amount of code that I write and with the time I spend writing it. So with like unit tests, it's usually the same amount of time spent writing a test that you spend writing a feature. Whereas like with integration tests, you probably spend a third of the time writing a test. So if you have a feature, it's like if you spend 3 hours writing a feature, it will take you an hour or less to write integration test for it. Which is, for me, like it's a big win. Like I don't want to spend time writing tests. I just like want to make sure that like the basic stuff works, get the tests in, and if they confirm what I think is true, then I just move on. Snapshot testing. So this one is an interesting one. First time I've tried snapshot testing about like a year or so ago, and then it was like all the hype and everyone was testing snapshot testing everything, like from snapshot testing components to like snapshot testing responses of the server, etc., etc. Since then, things changed. People realized that snapshot testing is very fragile, and basically anytime you change something, it breaks. So the use case for me personally became a lot more narrow. So there's like certain things that I use it for. So error messages, that's nice. Effectively, like I use snapshot testing for things that I know will be a one-to-one relationship. So for example, if you change an error message, you expect that test to fail and to have a different error message. In those cases, it's very easy to inspect things for me. I know how the error message has changed, and like I can just like hit U to update the test and be done with it. I don't need to like copy paste the error message myself and like figure out the right spacing, etc. Yeah, saves you time typing, and that's the main pro. Con is like you can't really do TDD. So again, as I said, like for snapshots, the use cases are like very limited for me personally. And let me show you some snapshot tests. So like literally what I've used snapshot tests for is obviously I'm testing my tests. So I'm kidding, I'm not testing my tests. This is just a custom assertion. So I'm testing that custom assertion, and on those custom assertions, there are a lot of error messages. So this is how like snapshot tests are helpful, in that if the error message is big, especially for like those custom responses, custom error messages, it becomes really hard to like find the right spacing and like mock it properly. And especially if you like want to test that it actually gets into that error message, it's hard to like change your test to work in a specific way so that you can see that error message. So it's much easier to actually like set up a test for that custom matcher. And like if you want to tinker with the error message, like if you want to add an extra tip, if you notice that like somebody is like continuously stumbling on those like particular pieces of that test, you like want to add some extra help there and like maybe link to something. This is how you can do this. So you can like literally with those snapshot tests, it's easy to inspect what my error messages are. It's easy to change them, and when I change them, it's very easy to like compare them. So it saves me the copy paste time, and since I expect my test to break, I'm happy to like pay the cost of my test being fragile. Sweet, end-to-end testing. This is another one of those things that a lot of people are excited about, and it's only exciting in the beginning, and then it's not so exciting. So who here is using end-to-end tests? Like Cypress or Puppeteer or Protractor or like other things. Sweet, so quite a few. Like, can you raise your hand again? Who's using end-to-end tests? I think more people are using end-to-end tests than like unit tests and regression tests. That's a little bit interesting. So we are using Cypress. It's been the new kid on the block about 6 months ago, like a year ago, and it's still working out quite well for us. We've toned down a little bit the amount of tests that we write. The reason we use Cypress is that the test setup is minimal. We have a lot of good guides for how to write good end-to-end tests, and like what should you test and what you shouldn't test. So again, like if you think about that app, I would only want to use end-to-end tests for something that's not covered by my integration test. So if you imagine like I've mounted that section in a DOM, I would need end-to-end tests only to make sure that if I mount like the actual real app with a real Apollo provider, I want to make sure that like the real provider is doing its job, it's getting values from the real server, and I only need a couple of tests to prove that. Once I know that like the actual layer that's being mocked by integration tests is working in the end-to-end tests, my end-to-end tests have like done their job. So by that logic, we have very little end-to-end tests that we actually use just to check like the main things, and even then like we are using them mostly for like smoke testing. So once you deploy your app, instead of the developer going through some tabs and like clicking things, you get Cypress to like do this for you and make sure that like nothing's like really broken and things are in places where you expect them to be. Sweet, video can't be loaded. Great. So I wanted to show like what the test run looks like, but effectively I can't do that. So visual regression testing, that's the fourth or fifth way. Yeah, I think that's the fifth. That's one of those things that like took me a little while to get accustomed to and learn. But once you have that set up, it works really well, particularly for pages that are like your marketing pages or like static pages that just consume content. Or if you structure your app using components. And like, I believe that like structuring your app using components is like one of the better or like leading ways of how to do things. Then visual regression testing can like help you a lot because you can test small pieces of your app individually to see if the changes that you've made to CSS haven't broken it. So there's two things here. So one is prevents accidental changes. That's the main one. So it may seem that, I don't know, like for me, about a year ago, it seemed like, what can you break accidentally? Like it's not that, it's very hard to like break things accidentally. If you change CSS, that you'll know you'll change some CSS, and you'll obviously go and check it. But in reality, what happens is you don't change your app that often, but for example, packages like React Select decide to change and go from regular CSS to CSS and JS, and they completely change how you are supposed to design those things. So if you've customized your select dropdown using CSS, now you need to change it to look exactly the same using CSS and JS. It can be a little bit of a pain, especially because it's very easy to miss all of those like different edge cases, your select boxes being in different places, then it's like highlighted when the dropdown is off, etc., etc. So all of those things, in the beginning it seems like, oh, why do I need to like set those tests up? But once you set them up, they actually can save your head quite often. So we use Chromatic plus Storybook for these. We chose Chromatic because it's hosted third party, so it's very easy to set up. It has all the features that you need, and it's a good pricing plan. So obviously we didn't need to spend too much developer time setting things up, and we can like write those tests and be done with them. And this, I'm not going to show how to set it up. The main benefit, like I've seen a lot of value from coming from those visual regression tests. Like if there's like two things that I could like recommend you taking from this is, one, invest a little bit of time in setting up your integration tests properly, so that you are not overly reliant on end-to-end tests. You don't do black box testing. And two, set up visual regression tests so that they'll give you a lot of value in terms of CSS. This is a showcase of what we actually have on RCR Popline. The only thing that we added is flow. And sorry, can I get a drink? Yeah. The only bit that we added to this is flow. And one thing that I'd like to mention since the last talk that really helped us a lot is actually adding contract tests in our ESLint. So even though ESLint is meant for like style checks, with GraphQL, it actually enables you to check that your contract is not being broken across your different repos. So we have a backend. Every time you deploy a change in the backend, our backend can run ESLint from the frontend repo and check that the fields that frontend uses are still there in the backend and nothing's broken. So it's really valuable. It has actually like saved us dozens of times from like taking down the production where people have like renamed or removed a field accidentally, thinking that it's not being used in frontend anymore, but like in reality it was. So again, it's like very easy to set this up with ESLint, but it provides a lot of value. And this is how our chromatic tests look like. So in this particular case, you can see that a change that we made to the library has been caught by our visual regression tests, because suddenly it started outputting HTML entities instead of actual values of those entities in the HTML, which was really useful. So we didn't embarrass ourselves. So yeah, that's a summary. Unit regression and snapshot testing, we use Jest plus Enzyme. For end-to-end testing, we use Cypress, and visual regression, Chromatic, and Storybook. So again, since I've given this talk about 6 months ago, nothing has really changed. Like we've added a couple of extra layers, like the contract testing that I mentioned with ESLint. But apart from that, this has been working really well for us. This the best kind of satisfaction from like writing your tests is when people actually tell you, oh man, like if I hadn't had that test, I would have like broken production. That's like the best kind of value that you can get. So yeah, that's like further reading and watching. They're like, this is a good one overview about like testing in 2018. Probably this will be out of date now. This one, definitely watch it. This is like, these are like the best practices that you can follow and do regardless of when do you write this, because they're like very general. And there's a blog post by Cypress about like the best practices for your testing. Again, I strongly recommend checking it out. It's the place where I learned about the data-test attributes and the fact that you can like use them instead of IDs, etc. So yeah, thank you. That's me. Thank you for listening, and withstanding this.